Hello guys, today I will teach you electric field. Electric field, it means the force experienced by charge. Force experienced by per unit charge. Suppose this is a source charge and we have to place here test charge. This test charge experience the force is called electric field or intensity of electric field. Suppose the separation between them is R, then force applied by the source charge on the test charge is F equals to Q naught R cap upon 4 pi epsilon naught R square. It is a vector form of force. So we can define in the form of F vector the force experienced by test charge Q naught is equals to Q R cap upon 4 pi epsilon naught R square. This term is called intensity of electric field. So we can write electric field E vector is equals to F vector upon Q naught. For the find of intensity of electric field, the magnitude of this charge, test charge, is very minute. So we can write in the form of E electric field is equals to Q naught limit tends to 0. This can be written as F upon delta Q. This is the force experienced by per unit charge is called intensity of electric field. In short, we can say it is an electric field. And the unit of electric field is Newton per Coulomb. Unit of force is Newton and unit of charge is Coulomb. So Newton per Coulomb. And the dimension formula of electric field is, the dimension formula of force is M1 L1 T minus 2 upon dimensional formula of charge is Coulomb Q equals to IT yani ampere T. So dimensional formula of electric field is M1 L1 T minus 3 A minus 1. This is the dimension formula of electric field. For positive charge, the direction of electric field, here listen carefully, the electric field is a vector quantity and it is dependent on the direction of force. That means the direction of electric field for positive charge, direction of electric field in the direction of, suppose this is plus Q charge and this is test charge, it is also known by nature is positive. So direction of electric field is, electric force is this and the direction of electric field is also in this direction. This is the direction of electric field also. That means we can say for positive charge, direction of electric field and direction of force are in same direction. This is of positive charge only. And for negative charge, for minus Q charge, suppose this is source charge minus Q, it is a minus Q charge and it is a test charge. So force is acting in this direction and electric field is acting in this direction. This is the direction of electric field. Sorry, we can write in this form. Suppose this is the direction of electric field and then here is charge, negative charge is placed, so it is attracted in this direction. So we can say for negative charge, the direction of force and field are acting in opposite direction. I repeat, for positive charge, electric field and force are acting in same direction, and for negative charge, electric field and force are acting in opposite direction. These 2 points are very, very important point. So remember it always. This definition of electric field in terms of force. And another format of electric field is E vector is equals to, this is equals to E. So E equals to Q R cap upon 4 pi epsilon naught R square. So here look here. Electric field is depend on the direction of unit vector R cap, and the force is also dependent on the direction of R cap. That's why we can say for positive charge, the direction of force and direction of electric field are acting in same direction. This formula represents the electric field in terms of charge and distance, and this formula of electric field is represented in the terms of force. So we can write here electric field is equals to F upon Q, or equals to Q R cap upon 4 pi epsilon naught R square. This is a very important term. Okay. Unit of electric field is Newton per Coulomb. Dimensional formula is m1 L1 T minus 3 A minus 1. Okay. Now we can move in on the topic superposition principle of electric field. The superposition principle of electric field is just similar to the superposition principle of force. In previous classes, I taught to you how we can find the superposition principle, or how we can find the net charge on the test, net force on the test charge. Similarly, in short, we can write in the form of electric field. E can be written as 1 upon, here remember, when in superposition principle we can write F 1 upon 4 pi is equals to I equals to 1 and I equals to n Q I Q naught upon R square, and here is R cap, R I J cap, I J. This is the superposition principle, and here is also I J. So Q naught is divided here. We have here F upon Q naught. This Q naught divided here, so this is equals to 1 upon 4 pi epsilon naught I equals to 1 to I equals to n I cap I, not ij. This is only for the I charge, single charge. So we can write Qi upon Ri square and Ri cap. This is equals to electric field E. So for superposition principle of charge for electric field is 1 upon 4 pi epsilon naught I equals to 1 I equals to n Qi Ri cap upon R square. And diagram related to just like superposition principle of force. Suppose this is test charge Q naught and position vector is R naught cap, and this is Q1 charge, and here is Q2 charge, and here is Q3 charge, and there are so many charges are distributed along the surrounding the test charge. This is the position vector is R2, and the position vector is R3, and similarly position vector is R1 vector. Now electric field applied by the test charge by Q1 charge in this direction, and electric field applied by these all are the positive charges, and this direction is acting in this direction. Sorry. magnitude of this charge is Q naught, and force is acting along this direction is this, and by this. This is E1, E2 and E3. This is called superposition principle for electric field, and the formula can be written as given by this formula. It is called superposition principle of electric field. Okay. Now the next topic. We have to take and distribute, and further for the further details, the distribution of charge for electric field. In previous class we have discussed the electric force, distribution of charges in terms of electric force. Now we can discuss the distribution of charge in terms of electric field. For linear charge distribution, formula is 1 upon 4 pi epsilon naught q lambda dl r cap upon r square. This is for linear charge distribution. L stands for linear, 1 upon 4 pi epsilon naught integration of 0 to L, 0 to A, sigma dA r cap upon r square. This is for surface area. And electric field in terms of volumetric distribution of charge can be written as 1 upon 4 pi L epsilon naught integration 0 to V rho dV dV r cap upon r square. This is the linear distribution charge, electric field for linear charge distribution. This is electric field for the surface charge distribution, and this is the electric field for volumetric charge distribution. And this term is equals to the electric field for discrete distribution of charge. So we can write the overall distribution of charge, including the uniform and non-uniform. We can write net electric field equals to E linear distribution of charge, E surface distribution of charge, E volumetric distribution of charge, and E discrete distribution of charge. So E net is equals to E linear distribution of charge equals to 1 upon 4 pi epsilon naught is a common, because the whole term is this is common. So we can write 0 to L lambda dl r cap upon r square. This is for linear. 0 to A or SA sigma dA r cap upon r square plus 0 to V rho dV r cap upon r square, and plus, this is for discrete manner, QI r cap upon r square. This is called whole distribution of charge by uniform and non-uniform distribution of charges. And for today's class, we have to conclude here, and in next class I will teach you electric field due to electric dipoles. Okay, and thank you very much.